Let's look at another example of applying Bayes' rule. In Series 4, Apple introduced ECG device in the Apple Watch. And this device can detect atrial fibrillation. And engineers give the following specification for this sensor. It was 98% true positive. So the probability that the test gives the positive result, given that the person has atrial fibrillation, is 0.98. And also the true negative was 99%, meaning that the probability that person doesn't have arterial test comes out negative, given that person doesn't have atrial fibrillation, is 99%. Okay, that seems quite impressive. This is a small device, and small device has very high detection rates of positive and negative cases. However, what we're interested in is the probability of a person having atrial fibrillation when atrial fibrillation is identified by the Apple Watch Series 4. We're going to use the Bayes rule to perform those calculations. So what we're interested in calculating probability of atrial fibrillation, given that the test from Apple Watch was positive. Okay, so we're just going to apply the Bayes rule. Probability of fibrillation given the positive test. It's probability of seeing positive test given that the person has arterial fibrillation times the prior probability of arterial fibrillation divided by the total probability of seeing a positive test. Okay. So we know this one that was given by the specification of the device. It was 98%. We can calculate the probability. Actually, we don't need to calculate the probability of the person having fibrillation. That's something we need to get from historical data. So prevailing rate of arterial fibrillation population is 0.02, so 2%. And then we need to calculate the probability of seeing a positive test, and we know how to calculate total probability. That's probability seeing positive test for a person with fibrillation times the prior probability of the fibrillation plus the probability of seeing positive test for a person without fibrillation and the prior probability of person not having the fibrillation. So this one is given to us. This one is given. This one is just 1 minus 2, so it's 98%. And this one is given to us. Well, what we know that we know the probability of seeing negative test given that the person has no fibrillation. But if we take 1 minus that, we will get this number. So if person doesn't have fibrillation, the test is either positive or negative. So this probability and this probability have to sum up to 1. So that's how we do the calculation. If we plug in everything into the equation, then we get 66%, which means that if you see alarm in your Apple Watch saying that you have arterial fibrillation, and you don't really know if you have arterial fibrillation or not, so you don't have any specific information about your chances of having it, then the probability of you actually having it is 66%. So if you think about applicability of this device, it's actually quite questionable, because when people see the alarm, they'll have to really question whether it's the true result or just a false alarm. 66% is not that high of a result. So from a marketing standpoint of view, you actually have to question whether something like this is a useful device.